Hello my friends, I welcome you all on India's largest live learning platform, that is Gradeup. My dear friends, I hope you are fine, and as you know that we are going with our SOM series, and today I will be discussing Poisson's ratio with you. So my dear friends, please listen my this session very carefully, and after the session, after discussing the concept of Poisson ratio, I will be taking some problems also. And my friends, believe me, if you listen all my concepts, then definitely you will be able to solve all questions. So don't worry, just watch the concepts that I am telling you about Poisson ratio, and then afterwards we will take some problems and you will solve it. Don't worry my friends, just share it with your friends also, so that they can also enjoy the session. Please like the video also. Okay my friends, this is the brief introduction about me, and you are watching me from so many days. Of course this will not be asked in your exam. Okay, so now the Poisson's ratio that we will denote, that I will denote with Greek letter mu. Poisson's ratio is minus of lateral strain upon longitudinal strain. Now my friends, the question arises, what is lateral strain? What is longitudinal strain? My friends, see, suppose this is a body, and if I apply a force in this direction, suppose some force is applied, and of course some stress has come due to that force. Of course here also there will be stress, I am not showing it, the body is in equilibrium my friends. Then my friends, the elongation in this direction, suppose I am taking this as x-axis, suppose I am taking this as y-axis, and suppose the axis that is coming out of the board, that is just coming to your head, out of the board is z-axis. Now my friends, if suppose this is the stress acting on this body, my friends, then my friends, this direction, that is elongation in x direction, is longitudinal strain. So my friends, see, I am again telling you, the longitudinal direction is that direction, the longitudinal strain is that strain which is acting along the force, and all other transverse directions, all other transverse strains are lateral strains. So strain in y direction and strain in z direction is lateral strain. Suppose I see here, again I am telling you, suppose this is a body, and if I apply a P force like this, then stress will be generated. Then my dear friends, see here very carefully, the shape of the body will be something like that. Okay, now this strain that is in the direction of force is longitudinal strain, and this strain that is 90 degree, that is transverse to the direction of force, is lateral strain. So we got to know that what is longitudinal strain and what is lateral strain. This in the direction of force, that is longitudinal, and this is lateral. Of course this, if I consider 3D, then the axis that is coming towards you, towards your head, that is also lateral strain. Okay, suppose in the same body my friends, see here, suppose in the same body my dear friends, this is the same body like this, and if I apply force like this, P and P, and suppose, let us suppose the deformation of the body is something like that, then in the same body, my friends, in the same body, now this will be longitudinal strain and all other strains will be lateral strain. My friends, see here, now in this same body, if the direction of force is like this, now this will be longitudinal strain, and this that is coming out of the board towards your head is lateral strain. So in the same body, longitudinal axis can change. My friends, here the body, this force, this direction is longitudinal strain, and all other strains, suppose this and this z-axis is lateral strain. Again here, my friends, this is longitudinal strain, that is in the direction of force, and all other strains are lateral strains. Okay, my friends, see, Poisson's ratio is minus lateral strain upon longitudinal strain, and my dear friends, see here, for this whole session, remember, my sign convention will be tension will be taken as positive, or elongation in strain, increase in length is taken as positive, and my friends, compression for this whole session I will take as negative. Tension as positive, compression as negative. I am taking this in convention, my dear friends. Okay. Now mu is, see, for this body, suppose I name this as 1 and suppose I name this as 2. My friends, see this. So for this second body, mu is minus lateral upon longitudinal. So lateral strain, suppose consider 2D only x-axis and y-axis. Don't consider 3D. So for this body, my friends, what is longitudinal strain? Longitudinal is this, that is in direction of force, is positive. This is positive, and lateral, that is decreasing in this direction, that is negative. So negative upon positive will be negative, and one more negative. Therefore mu will be positive. See for the first case, this longitudinal is positive, that is in the direction of force, and lateral is negative strain because length is decreasing. Here length is increasing, therefore positive. Again positive by negative, one more negative sign, therefore mu will be positive. Therefore mu will be positive. Okay, my friends, let's go further. See, mu, I have written the values of mu for different materials. So these are the values of mu. For cork it is 0. See, if the cork is like this, see my friends, suppose this is cork. So if I apply some P force and P force here, so in this direction there is longitudinal strain because this is longitudinal axis. Where the force is acting, that is axis is called longitudinal axis, my friends. So mu of cork is 0. And what is mu? Mu is minus of lateral strain upon longitudinal strain. So mu for cork is 0. Therefore mu is 0 means lateral is 0. Lateral strain is 0. Therefore the elongation of this body will be only like this. Only longitudinal strain will be something. There is no lateral strain because mu is 0. So these are the values of mu for other materials. This is the value of mu for cork. And my friends, please see here. Mu for polymer and human tissue is negative. My friends, mu for polymer and human tissue is negative. That means, suppose, see, this is polymer or human tissue. This is suppose polymer or human tissue. And if I apply force like this on polymer and human tissue, then my friends, the deflected shape, since mu is negative, my friends, since mu is negative, therefore mu is negative, therefore these both are of same sign, then only negative will come. Then my friends, for this polymer and human tissues, my friend, deformation will be like this. Because for polymer and human tissues, my friend, for polymer and human tissues, mu is negative. My friends. Mu is negative. Mu negative means, mu is this, negative means these are both of same sign, then only this minus will come. These both are of same sign means if I am applying force like this, then this also increase, so this will be positive, negative will remain, that is coming here. Similarly, if I apply compressive force, then this direction decrease, this direction also decrease. Okay, for all other materials like these, see my friends, for all other materials like these, since mu is positive, therefore for them, if I apply force like this, then their deflected shape will be like this, normal. One will be plus, longitudinal, other will be minus, so there will be minus upon plus and one more minus, therefore the values will be positive. Okay, now my friends, question, a genuine question to all of you is that you all will be having one genuine question that, sir, how can this be happen, sir? How can this happen, sir? We are not able to visualize. Sir, how this can happen that it is increasing in this direction also, in this direction also? So, sir, how this can happen? This is increasing in this direction and it is not decreasing in this direction. I am not able to get, sir. How this can happen, sir? Okay, these sir, for these values, for these concrete, steel, aluminum, iron and rubber, sir, I am visualizing this, but I am not able to visualize this. My friends, you are not able to visualize this because there is a wrong concept in your mind, and that concept is, my friend, that concept is volume is constant. You all believe that volume is constant. No, my friends, volume is not constant. Volume can increase or volume can decrease, my friends. Volume can increase or volume can decrease. See here. Suppose this is the atomic structure. These are all hinges. These are the atomic structure of human tissue or polymer, suppose. For human tissue or polymer. And if I apply a P force like this and like this, then this will elongate to in this direction and this will be like this. So volume can increase, my friends. Volume can increase. So these are the values of mu. Now, my friends, hello Shruti, hello ABC, hello Pushpraj, how are you all? Hello Vidya, hello Debashish, hello Anshika. No, Anshika is asking, my all friends, Anshika is asking that the can be greater than 1. No, Anshika, mu cannot be greater than 0.5. For any material in this earth, mu is not greater than 0.5. My friends, please, whoever watching this video, hello Ishu, please, my friends, whoever watching this video, please like it and share it with your friends so that they can also get benefited. My friends, please see here now. These are the values of mu. Now, my friends, question can come that, and it has already been asked that what is the value of mu. So, the value of mu ranges from minus mu to 0.5. This is the value of mu. Mu can range from minus 1 to 0.5. Of course, Utkarsh and Rishi. Hello, my friends. Of course, Utkarsh and Rishi. And all of you, the mu negative will be for human tissues and polymers. Okay. My friend, in exam, sometimes in gate also mu is given like this, and sometimes answer is given like this. The range sometimes given like this, sometimes like this. Now, my friends, how to write? If you have to write this option correct or this option correct, depends on the question. If in question it is asked that find the value of for engineering materials or engineering metals, then answer will be this. And if it is asked find the value of mu for all substances in earth, in which polymer also comes and human tissue also come, then the range will be this. I am again saying, if for all substances in earth it is asked, then mu will be this, and if for metals it is asked, then range will be like this, my friends. Okay. Let's go further. My money, mu cannot be greater than 0.5. Of course, there is no derivation in any book in this world that is a value. No one can derive that. Hello Utkarsh, hello Babita. Let's go further. Please, all of you like this video. And share it with your friends also. Yes, Rishi. We don't take, see, all of you, my friends, Rishi is asking, sir, but we don't take negative value in Poisson ratio. Rishi, because unless mentioned, we are dealing with metals in SOM. We are dealing with metals, not with human tissues and polymers. Therefore, unless mentioned, there is no value of negative mu in our exam. Always it is, we are dealing with steel, aluminum like that. I hope, Rishi, you got it. Okay, my friends, I am just, who have joined later, my friends, see, I am just repeating what I have told you till now in just 1 minute. So those who have joined later, just see, I have told you till now that mu is equal to minus of lateral strain upon longitudinal strain. And what is longitudinal, what is lateral? Suppose in this body, I apply some force like this. Suppose stress is coming due to that force sigma. Of course, sigma will be here also. Then this direction is longitudinal and all other directions are lateral. Okay, suppose in this same body, if I apply force like this, then this will be longitudinal and all other direction will be lateral. Mu will be like this. This is mu. Now see, I am going further. See, now very carefully see all of you. All of you now see very carefully. My friends, this is the value of mu, and for this whole session, my friends, I will take this axis, that is x-axis, that is going towards right of your mobile or laptop, whatever. This axis I will take as y-axis, and this axis that is coming out of the board towards your head, that I will take as z-axis in this whole session. In this whole session, tensile stress I will take as positive, compression as negative, elongation in strain is I will take as positive, and contraction negative. Let us start the session now. See, first of all, I am considering the uniaxial loading, and this is the body. I want to find out epsilon x. So my friends, if you remember my video on elastic constant, then I have told you that stress by strain is Young's modulus only for uniaxial loading. That time I told you stress by strain is Young's modulus only for uniaxial loading, and here my friends it is uniaxial loading. So stress by strain is Young's modulus. So strain will be stress by Young's modulus. So epsilon x is equal to sigma x by E. Now my friends, since this here it is elongating, of course it will contract in other directions also. Then I want to find out epsilon y. Then my friends, see, Poisson ratio is lateral strain, epsilon y is lateral, epsilon x is longitudinal, lateral by longitudinal. Similarly, epsilon z by epsilon x. If for this y is lateral, then z is also 90 degree. That is also lateral. That is also lateral. So this is also lateral by longitudinal. So from here we can say that from these two, I can say that epsilon y is equal to epsilon z. And how much epsilon y is equal to epsilon z? It will be minus mu epsilon x. And what is epsilon x? Epsilon x is sigma x by E. So it is minus mu sigma x by E. It is minus mu sigma x by E. Okay, this is epsilon 1, epsilon z. And this is epsilon x. My friends, see here. My friends, see here. This is epsilon x, this is epsilon y, this is epsilon z. My friends, see very carefully. This is what I have told you by formula. Now see how to feel it also. My friends, if on this body I am applying force like this, then it will elongate more in this direction, that is x direction, that is longitudinal direction. So this value is more. And my dear friends, see, these values are small. Mu value is less than 1, even less than 0.5. So this is bigger magnitude and this is smaller, because here mu is multiplied and mu's magnitude is less than 1, even less than 0.5. So this is small. Of course you can visualize it also यार, you can visualize it also. अगर मैं यहाँ से लोड लगाऊंगा ना, तो ये बढ़ेगा ज्यादा और बाकी y और z डायरेक्शन में घटेगा कम. If I apply load, then it will elongate more in x direction and compress y and z direction less. My friends, you all will be knowing this, and that less value is this much. Why it is minus? If I am applying load in this direction, then of course it will elongate in this direction, therefore positive, and it will contract in other directions, therefore they will be negative. So you can feel it also yaar. Okay. Yes, Rishi. Let's go further. Now this is the case of multi-axial loading. My friends, now I am going with multi-axial loading. See here, I am saying this axis as x-axis, this axis I am taking as y-axis, and axis that is coming out of the board, that axis I am taking as z-axis. Okay. Now, of course, my sign convention is tension is positive, compression is negative, of course elongation in strain I will take as positive, and compression I will take as negative. This is my sign convention for the whole session. Okay, my friends, see here. Now in this multi-axial loading, suppose here stress is acting sigma x, here stress is acting sigma y. Of course, my friends, here stress is sigma x na, then here also stress sigma x. Body is Body is in equilibrium. I am not showing that value. And here in z direction stress is sigma z. Now my friends, please very carefully see it. I want to find out the epsilon x value. See, this looks like E. I want to find out epsilon x value. I want to find out epsilon y value, and I want to find out epsilon z value also. I want to find out epsilon x. I want to find out epsilon y. I want to find out epsilon z. Okay, my friends, see. So epsilon x will be, first of all, I want to find out the strain in x direction. Then first of all, forget this. Due to sigma x stress, what will be strain? It will be sigma x by E. Sigma x by E. What I have done, I have forgot these two. So due to sigma x, what will be strain? Sigma x by E. See that, yaar? See that. Now forget these two. Forget these two. Forget these two. Due to sigma y, what will be stress in x direction? It will be minus mu sigma y by E. Remember? See this. My friends, see this. Due to stress in other directions, its stress is like this. Similarly here, it will be, if this is y, forget this. If this is if this only stress is acting this, forget these two. This is longitudinal and this will be lateral. So lateral will be sigma x by E. Of course minus, because if in this body I am elongating it here, if I am elongating it here, it will contract here. If I am elongating here, it will contract here. Therefore minus. Similarly, now forget these two due to sigma z. If I elongate it like this, then it will contract here by mu times, by mu sigma x by E. Similarly, I want to find out epsilon y. So epsilon y will be, forget these two. Epsilon y, strain in y direction due to this, will be, strain in y direction due to this, will be sigma y by E. And strain, now forget these two. Strain in y direction due to this, forget these two. Now y is lateral to this. So it will be how much? It will be minus mu sigma x by E. Now forget these two. Due to this, it will be minus mu sigma z by E. If you are not getting, I am telling again. My friends, see here. I am explaining this. Epsilon z. If you don't get these two, I will explain this in detail. See, my friends, keep liking the video. Okay, see here. In z direction, forget these two. So in z direction, strain due to z direction stress. Strain due to z direction stress will be how much? It will be sigma z by E. Now, my friends, forget these two. Due to sigma x, the strain in z direction, that is lateral, will be minus mu sigma x by E. Similarly, due to that will be minus mu sigma y by E. So this is the strain in z direction, this is strain in x direction, and this is strain in y direction due to multi-axial loading. Okay, Rishi is saying there is sigma z in first equation. Of course, yes Rishi, yes, this will be sigma z. Okay. Okay, see, concentrate here. Let's go further. These are strain in x, y, z direction. Okay, my friends, now I want to calculate volumetric strain. Volumetric strain is delta V by V, change in volume by original volume. Okay, see, suppose this is a body and this is length is L, this is B and this is D. So delta V we write as this, like this we have to write delta L BD plus delta B into LD plus delta D into LB. Okay, this I write delta V. Okay, now I have to find volumetric strain. So volumetric strain is delta V by V. So we divide it by LBD. Okay, so volumetric strain is delta L by L. plus delta B by B plus delta D by D. Now volumetric strain is epsilon x plus epsilon y plus epsilon z. So this is the volumetric strain. This is the volumetric strain. Pawan, it will be better if you concentrate here. Okay, volumetric strain will be epsilon x plus epsilon y plus epsilon z. Now my friends, see here very carefully. Volumetric strain will be epsilon x plus epsilon y plus epsilon z, and epsilon x, epsilon y, epsilon z I have already calculated. Here. So my friends, see here. So volumetric strain I have derived that volumetric strain is epsilon x plus epsilon y plus epsilon z. Then okay, good Pawan. Epsilon x plus epsilon y plus epsilon z. Then we have to add these three. So 1 by E is common. See, sigma x, sigma y, sigma z alone, they are alone one time. So sigma x, if I take sigma x plus sigma y plus sigma z common, they are alone one time. They are alone without any coefficient. And sigma x is with mu 2 times, 1 here. Similarly, sigma y with mu is 2 times, 1 here. Similarly, sigma z with mu 2 times, 1 here with mu. So 1 minus 2 mu. So my friends, this is volumetric strain. You have to remember this formula. Okay. Now my friends, let us take some questions. Okay, please my friends, solve this question. I want quick response yours in your comment section. Find the value of sigma for Poisson ratio volume change 0. So I have derived you that volumetric strain is sigma x plus sigma y plus sigma z into 1 minus 2 mu by E. So volumetric strain will be 0 either if this term E can't be 0. So volumetric strain will be 0 if this is 0 or this is 0. So for this to be 0, mu should be 0.5. But here mu is not 0.5, mu is how much? Mu is 0.3. Remember my friends, for rubber I have shown you that mu is 0.5. Therefore rubber, if any stress is acting, for rubber volume change will be 0. Okay. So here this can't be 0 since mu is 0.5, mu is 0.3. Therefore sigma x plus sigma y plus sigma z is equal to 0. We have to write these stresses with proper sign convention. How much is sigma x? 175. Since tensile, therefore I have written plus. Sigma y is 50 plus. Sigma z is minus. Since compression, I have told you sign convention. Minus 22.5 is equal to 0. So this is 225 is equal to, this is 22.5 sigma. So this is 22.5 sigma. Therefore sigma is 10. So option A. Very good. Okay, let us take the next question. The deformed shape is like this due to these kind of stresses. 5, we have to find out Poisson's ratio. So mu they are asking. What is mu? And see, plane strain condition means you have to consider 2D, not 3D. You have to consider 2D, not 3D. Okay. Volumetric strain is asked. No, Poisson's ratio is asked. Okay. Let us take epsilon x. I am taking this as x-axis, this as y. Of course, there is no z because plane stress condition is asked. So, my friends, epsilon x is how much? Change delta upon L. So, how much is delta? Delta change from here, delta change from here. Therefore, 2 delta upon length. Length is L. So, epsilon x is 2 delta by L. And due to epsilon x, due to this P stress, the unit of P is this. So, P is stress, not force. You will see the unit. So, it will be P by E. So, I want to find out strain in this direction. that is x direction, epsilon x. So due to this P, this is acting in this direction, how much it will be? It will be P by E. Of course, we have to remember sign convention also. Therefore, minus P by E. And due to this, you can write minus mu P by E. And this P is in compression. Therefore, it will be plus mu P by E. Or you can feel it also, yaar. If this, due to this P, it will expand here. Therefore, plus. You can feel also. Otherwise, from the formula that we have discussed, like this minus mu sigma y by E. So, this is also minus because this is compression. Therefore, it will come plus. Now, my friends, see. Delta is given. L is given. Young's modulus is given. P is given. So, I am not wasting your time in calculation. So, from here you can find out mu. So, my friends, from here you can find out mu. Okay, whatever value you are getting. Okay. Now, my friends, do this question. Sigma ZZ is 0. So, this direction there is no stress. Young's modulus is given. Sigma XX given, sigma YY given, and strain is asked in ZZ. Okay, Rudra is saying B. Okay, good, Rudra. I want all other answers also. Okay, see, epsilon ZZ is how much? Epsilon ZZ is how much? It will be, since sigma Z is 0, we have not considered that term. It will be sigma Z by E. First, let me write the formula. Minus mu sigma x by E minus mu sigma y by E. But this will be 0 since it is given. So, epsilon ZZ is asked. It will be minus mu sigma x by E and minus mu sigma y by E. So, minus mu by E common. Sigma xx how much? It is 30 megapascal. 30 megapascal, that is 30 into 10 ki power 6 Pascal, plus mu sigma y. So mu is common, therefore sigma y is remaining. But sigma y is in this direction. Therefore it will be how much? 50 into 10 ki power 6. Okay, E is given, mu is given to you. Mu is how much? Mu is 0.3 and E is given. So epsilon ZZ we can find out. I am not wasting much time in calculation. I hope this minus 120 into 10 ki power minus 6 answer will come. Okay. So like this. Now let us move to the next question. Okay. If Poisson ratio of material is 0.5, then elastic modulus is these 4 options. And my friends, remember my video elastic constants. There I have told you about these. E is Young's modulus, G is shear modulus, mu is Poisson ratio, and K is bulk modulus. Take this screenshot for further reference. Take this screenshot. Okay, now it is this. So we know that this, see this first formula or this second, E is equal to 2G 1 plus mu. So E is equal to 2G 1 plus mu. Okay. So E is equal to 2G, mu is given how much? 0.5, 1 plus 0.5. So 1.5 into 2 is 3G, E is equal to 3G. So elastic modulus is 3 times of shear modulus, like this. Okay. Yes, very good Avinash. Keep it up. Let us take next question. This, what is given? Modulus of rigidity is 70 gigapascal is given and bulk modulus is given 150. You have to find out what? You have to find out E and mu. E and mu you have to find out. Okay. Okay, yes, the previous answer was A. Good, good Venkat, good Bhatt. Ravindra Bhatt, excellent. solve this question now. Solve this question. Okay, see these formulas. E is equal to 9 kg upon 3k plus G. E is equal to 9 kg upon 3k plus G. 3k plus G. K and G are given. So from this calculate E. From this calculate E, it will kg is given here, yaar. So from here E you will approximately get as 182 gigapascal. Okay. Now remember the formula. E is equal to 2g 1 plus mu. This was also formula. We have got G is here 70, so mu we will got as 0.3. So this will be the correct. I am not wasting most your time in calculation. Okay. So my friends, okay. Now my friends, see, this is our course Vision 2021, and my friends, we have started the preview period in which you can watch many videos in Gradeup app just on your Android phone. Install the app Gradeup and you can take the free trial that we have started from 5th January. Of course, that is free trial. You can watch the videos and recommend your friends also. Just install the Android app. And my friends, from 20th January, I am starting the first subject, that is civil engineering. First subject of civil engineering, that is surveying. And every subject will be taught to you in full detail by covering GATE and other competition exam syllabus. You will be getting quizzes according to GATE also and according to IS also after every class. Our different experts of different subjects will be teaching the course throughout the year, and all topics will be taught to you. So free trial is available on Gradeup app. Just on your Android phone, install the Gradeup app and you can take the free trial and see the classes there. Okay, my friends. Also in your Gradeup app, you can write Abhinav Negi. And you can follow me. There are many quizzes and mock tests available for you. Just write Abhinav Negi and follow me there on Gradeup app. My friends, this is green card. By taking this green card, you can access more than 130 plus mock tests for GATE also and for other competitive exam also. My friends, I hope you like the session. Please, all of you who are there, please, I want your like. Just share it with your friends also, so they can also be benefited. Okay, please like it, share it and follow me, that is Abhinav Negi, on Gradeup app. Okay, my friends, I hope you have a wonderful session. Just prep smart, score better, go Gradeup. And remember, tomorrow at 9:30 p.m. my friends, at 9:30 p.m. I will be again for Poisson ratio part 2, in which I will be dealing more problems of temperature stress combined with Poisson ratio. 9:30 p.m. tomorrow. See you then. Have a good night. Thank you.